Welcome to the Senior Industrial Leadership Training. My name is Santosh Raikar, and I've spent over 30 years in industrial operations. This course is specifically designed for those stepping into maintenance and engineering leadership roles within large-scale process and manufacturing environments. Over the next hour, we will walk through a comprehensive 365-day development plan designed to move you from initial entry to high-performing system governance. Let's start with a foundational premise. Experience is your greatest asset for accelerating judgment, but discipline is what protects that judgment from bias. As a seasoned leader, you'll likely read a plant faster than most, but you must remain disciplined in separating what you observe from the evidence at hand. We start by walking the value stream to see the operating reality, challenging every story you're told with long-term data trends, and acting immediately only where delay poses an unsafe risk. For everything else, we investigate before we change the system. Our journey is structured around 6 critical decisions that every new leader must make in sequence. We begin by entering the environment to establish trust and control immediate risks. From there, we diagnose the current state, organize the funding based on cash consequences, integrate maintenance and engineering into a single life cycle, develop the people, and finally install the governance routines needed to sustain these gains long term. It is vital to clarify your role charter early on. The leadership test isn't about how much activity or work the maintenance department did. It's about how well the asset system balanced performance, risk, and cost. Our mission is to protect value. This means delivering safe, compliant operations and stable throughput by managing everything from mechanical integrity to spare parts control. We are not just fixing machines. We are delivering a required plant function at an acceptable risk. To understand the ground truth quickly, I suggest asking these 10 questions. The first 5 focus on the physical asset reality, where the value is lost and what constrains the plant. The second 5 dig into the system and culture, what has been deferred and why, and most importantly, which numbers are actually trusted by the workforce versus those that are just reported for the sake of appearances. During your entry, you must operate at 2 speeds. You must be decisive and act immediately on intolerable risks like safety exposures or failed interlocks. However, you must be patient and verify before changing systemic things like organizational structure or PM frequencies. A seasoned leader knows that some practices might look unusual but actually work within a specific context. So diagnose thoroughly before you disrupt the workflow. This roadmap outlines your first year. The first 90 days are about containment, baselining, and stabilizing work control. As we move into the 4 to 12-month window, the focus shifts toward reforecasting budgets based on risk and optimizing asset strategies. By the end of the year, we are no longer just reacting, we are building institutional capability. The first 30 days are what I call an evidence suite. You need to look at 4 quadrants: the field, the people, the work processes, and the data. By day 30, your output should be a single-page plant loss map and a risk register. This prevents you from being busy without being effective and sets your priorities for the next 90 days. In your diagnosis, always begin with the value stream. Understand how energy and raw materials move through your conversion assets to become a product. By building a loss tree, you can quantify exactly where the business is hurting, whether it's unplanned downtime, rate losses, or quality issues. This allows you to speak the language of the business, connecting technical failures to margin impact. To avoid a confident but wrong baseline, use triangulation. Compare what you see in the field with what people tell you and what the data shows. When all 3 agree, you have high confidence. However, when there's a conflict, for example, the data says a machine is fine but operators are struggling, don't ignore it. Treat that mismatch as a finding in itself. When establishing a risk baseline, remember that criticality starts with consequence, not averages. We use a standard probability consequence matrix, but we apply a hard gate for safety and environmental risks. A key rule here is that a single intolerable consequence, like a major safety event, can force action even if the calculated probability is low. We don't average out human safety. Asset health shouldn't be a gut feeling. It needs a score, a trend, and a confidence rating. We look at condition, performance, history, and supportability. It's important to remember that these weights are plan-specific. Also, never allow a high-risk statutory item to be buried or hidden inside a weighted average. If a pressure vessel is out of compliance, that fact must stand out regardless of the overall score. Audit real work, not just the dashboard. Take a sample of 50 to 100 closed work orders and look for the story they tell. Is there a clear problem cause remedy history? Are the costs and labor hours accurate? A precise looking KPI is completely useless if the underlying work history is unreliable. We need to ensure our data reflects the reality of the shop floor. Your KPI architecture should connect daily behavior to business outcomes. We track 5 levels: business impact, asset performance, the work system, technical health, and capability. The goal is to use the smallest set of metrics possible that actually changes a decision. If a metric doesn't lead to action, stop tracking it. Benchmarks are useful for starting conversations, but they must be interpreted with care. For instance, while a mature plant might aim for less than 5% emergency work, you must ensure you're classifying emergencies consistently first. Use these ranges as a screening tool to identify where your plant might be deviating from industry norms, but don't treat them as absolute law without context. It's important to distinguish between standards, benchmarks, and local targets. Standard define what is required by law or safety, like OSHA or ISO. Benchmarks are peer comparisons. Local targets, however, are decisions made by the plant based on its own risk appetite and baseline. Never label a rule of thumb as an industry standard. Be clear about why you've set a specific goal. Moving to the financial side, budget leadership starts with risk transparency. Think of your maintenance budget not as a cost center, but as a portfolio of decisions. Every line item should be organized by its business purpose, its criticality, and the consequence to the business if that spend is deferred. This moves the conversation from how much can we cut to how much risk are we willing to accept. To manage the budget effectively, separate your costs into categories. Start with the mandatory base, safety and legal compliance, and move through sustainment, outages, and reliability improvements. By tagging each line as OPX or CAPEX and identifying which are committed versus forecast, you give yourself the visibility to manage cash flow through various business cycles. When a stakeholder asks to defer a project, remember that the cost of deferral is an engineering calculation, not just a financial one. It includes the increased probability of failure, collateral damage, and a recovery premium, the extra cost of fixing something in an emergency rather than in a planned window. Always report a range of confidence so the decision maker understands the potential downside. We use a disciplined cash gate to make the spend or defer decision defensible. Is it mandatory? Is the exposure credible? Can the risk be controlled in the meantime? If the risk reduction justifies the cash, we spend. If we can control the risk through monitoring, we defer. If the evidence is weak, we stop or redesign. This keeps the decision-making process transparent. Every single budget line needs what I call the 4 truths. You must be able to state its business purpose, the accounting treatment, the exact timing, and a specific risk if it's deferred. Most importantly, how will we know the spend actually worked? Avoid calling risk reduction savings. Instead, focus on the value of the risk retired. Managing cash means timing your portfolio. By looking at a 13-week cash profile, you can distinguish between committed obligations and forecasts. Risk opportunities are areas where cash can be moved, but only if explicit risk controls are put in place. This visibility allows you to be an agile leader when the business faces financial pressure. Deferred maintenance must never become invisible maintenance. If we decide not to fix something now, it goes onto a deferral register with a named owner, a monitoring plan, and a hard expiry date. For example, if we have a bearing trend, we might monitor it weekly with a trigger to act if vibration increases by 25%. This ensures we are managing the risk, not just ignoring it. Here is a concrete example of how risk calculations clarify spend. by spending $85,000 to intervene on a critical pump, we reduce the failure probability from 18% to 4%. When you multiply that by the $1.2 million consequence, the expected loss reduction is $168,000. That's nearly a 2 to 1 return on investment in the first year alone. This is how you justify your budget to senior executives. When presenting to executives, keep your ask to one page. State the situation, provide the evidence, outline the options, and make a clear recommendation. Keep the technical details in the appendix. The goal is to make the decision logic visible so that the executive can clearly see the choice between funding an action or accepting a risk. Seasoned communication is precise about uncertainty. Instead of saying, maintenance needs money, say this phase decision retires a quantified exposure. Be clear about what are facts, what are consequences, and where the uncertainties lie. This builds your credibility as a leader who understands both the engineering and the business reality. Now let's look at the operating model. Maintenance and engineering are often separate departments, but they share one asset system. From operations setting limits to engineering managing changes, every part of the life cycle must connect. Common control points, like a shared asset hierarchy and failure learning, are what keep these functions aligned toward the same mission. To close the life cycle gap, we use a RACI matrix. It is critical that for every decision, whether it's PM strategy or project commissioning, there's only one accountable owner. While many may be responsible or consulted, clear accountability ensures that nothing falls through the cracks between operations, maintenance, and engineering. Work management is the engine of predictable execution. It's a multi-step process from identifying a defect to learning from the repair. We track metrics like break-in work and plan accuracy to ensure we aren't just fixing things, but are constantly improving the system to prevent the next failure. Predictability is the hallmark of a mature maintenance organization. Asset strategies should be driven by failure behavior and consequence. If a measurable condition exists, use condition-based monitoring. If failure is age-related, use time-based restoration. If no proactive task works and the consequence is unacceptable, you must redesign the asset. Every task must be technically effective and have a clear acceptance limit. Outage success is determined before the equipment ever stops. We use a gated governance process to move from a business case to execution. One of the most important rules is the freeze. Once the scope is frozen at G5, any new work requires a rigorous change control process. This prevents the scope creep and resource dilution that often lead to outage overruns. Your spare parts policy must balance availability with cash. We categorize spares based on their consequence and supply risk. High consequence, high risk items become insurance spares, while low risk items are managed through standard replenishment. This ensures we have what we need for critical failures without tying up unnecessary capital in the warehouse. Engineering is responsible for the entire asset lifecycle, not just new projects. They define the limits and manage the management of change in the MOC process. There must be a continuous feedback loop. Maintenance reports repeat failures and access issues to engineering, while engineering provides the technical basis and operating limits back to maintenance. When it comes to your people, you must know the team through evidence, not reputation. Use 5 different views: conversation, field observation, work evidence, practical demonstrations, and formal qualifications. The competency matrix should never be a punishment tool. It is a risk management instrument to identify where the team needs development. A good competency matrix shows coverage, depth, and risk. It identifies single point dependencies, those areas where only one person knows how to perform a critical task. We prioritize closing these gaps based on the criticality and frequency of the work. This helps ensure that the plan's success doesn't depend on the presence of a single individual. Development plans should end with demonstrated capability. We identify a gap, assign real work as a stretch assignment, provide coaching, and then require a practical demonstration before authorizing the individual for that scope of work. This systematic approach ensures that training actually translates into field performance. Culture is what the system rewards when the pressure rises. A true reliability culture is one where production pressure never bypasses safety, where precision work is the norm, and where people are recognized for finding weak signals of early defects. Most importantly, never celebrate the emergency hero more than the team that prevented the emergency from happening in the first place. Culture follows routines and consequences. If you want people to escalate defects early, you must thank them and assign an owner when they do. If you want to protect plan work, you must challenge the priority of break-in requests. Your response as a leader to daily events is what eventually hardens into the plant's culture. Before you look outside for benchmarks, look inside. The strongest best practice might already exist on another shift or a different production. Discover these positive deviations, understand why they work in your specific context, and then standardize and scale them across the entire plant. This internal learning is often more effective than importing generic solutions. Finally, we maintain the operating system through a governance cadence. Daily meetings focus on immediate abnormalities. Weekly meetings focus on the schedule and risk. Monthly and quarterly reviews focus on long-term trends and strategy. These meetings are not for status narration. They are control loops meant for decisions and escalations. After 12 months, your deliverable is a working system. Success isn't defined by having zero maintenance costs. It's defined by predictable value delivery and transparent, accepted residual risk. By the end of the year, the system should be improving through its own governance rather than through individual heroics. As we conclude, remember the senior leader's ultimate test. Leave the plant with a system that makes good decisions even when you aren't there. See the reality clearly. Make the connection between risk and cash explicit, and develop your people and your system together. Thank you for your time, and I look forward to your questions.